Okay, so I'm excited. I'm trying a new device. We bought a Surface Pro a few years ago for our daughter for college, and she didn't really like it. So we have it still, and I decided to try this for my math lectures. So we'll see how it goes. I'll see if I can use, because it's got the touch screen on it, so I can hopefully write out math that's a little bit more legible. Okay, so this is your lecture for Monday, which is May, gosh, I can't believe it's May, May 4th, and it is, should be under day 5, I believe. We should be under day 5 now. Let me double check. I've got 5 million things going on here. Yes, we're under day 5. So I'm breaking down this algebra in one PowerPoint, then a little bit more on Friday. So this is for Monday, May 4th, first day of Pre Algebra, and this actually comes out of Unit 9 in your textbook. So we're kind of following out of order. All right, so kind of a review, or what we talked about, I guess, basically the first day on whole numbers is we'll be talking about integers. Okay, those consist of positive and negative numbers and the number 0. Okay, so this little graph comes out of page 201 in your textbook. So integers consist of positive whole numbers and their negatives and the number zeros. Integers form a countable infinite set. Okay, so looking at the number line, reminding yourself that on the right is always greater than the numbers on the left. Okay, so generally to the right of 0 then are going to be your positive integers, and then to the left of your 0 is going to be your negative integers. Okay, so we'll be talking about absolute value a little bit, defining that so you're able to recognize that on a test. I want to ask what's the absolute value of a number. So the absolute value basically tells us the distance from the 0 on the number line. How far are you from the 0? So like the absolute value of -5, and that's generally written with the 2 bars on the side. The absolute value of -5 is 5. Okay, just like the example there with the number 4, -4, written with the bars on the side. So that's basically saying the absolute value of -4 is 4. And then of a positive integer, it's going to be a positive number. So the absolute value is always going to be a positive number because it's just saying how far away from the 0. And then the part on the left side of the equation is telling you, is it on the left side of the 0 or on the right side of the 0? Okay, so another example here, the absolute value of the number 3 then is shown as this. That's how it should be written, with the lines on the side, the straight bars. And that is indicating the distance of the number from the 0. That is why the absolute value is never negative. Okay, so again, absolute value is asking only how far, whether the number is in a negative or a positive direction on the number line. Okay, so 3, the absolute value of 3 then is 3 to the right of 0, and then the absolute value of -3 is 3 to the left of the 0. Okay, so pages 201 and 202 in your textbook further explain that if you need more clarification. 8. We're going to get this right yet here. So I have -4 is where I started at, and it's asking me to add 8, but it's a +8, okay, a positive 8. So I'm going to go 1, 2, 3, 4, 5, 6, is going to be a positive 4. If that was a negative 4, so this is negative 4 plus 8. So that's giving me a negative, just a regular 4. I'm sorry. If I were to do it the other way, let's say this looked like negative 4 plus a negative 8. I look at that as it's putting me further into the hole. Okay, again, my 8's the bigger number. There's a negative in front of it. That's going to be negative 12. Okay, so I would move 8 spots the other way. So that would be negative 12. Okay. All right. So hopefully that helps. I'm getting through this here with this crazy little mouse and the little writer thing. All right. So subtracting integers. Now the book kind of makes this a little confusing, I think. Of course, I can be confusing too, I know. So this is again on page 205, kind of starts talking about this for you too. So we have the example here of a plus 5 minus a negative 9. Okay. Now I was always taught that if I had two negatives, I would just turn it into a positive. This kind of explains it a little bit differently. It says to change it to a positive, but then still keep the negative 9, but then change the number sign on the right. So then change it to a plus. I don't know. I've just always stuck with the rule of two negatives equal a positive. Okay. All right. Let me see. The nice thing about this one is it doesn't make, yeah, good. So this is one of the examples I had. So if we had a negative 9 minus a 4, what is that going to equal? Okay. So if I do what the book told me to do, okay, if I actually change the negative sign to an addition sign, then I'm going to have a negative 9 plus a 4, but then it tells me then to change to the opposite side of the 4, so that I would change then the 4 to a negative 9 again, plus a negative 4. Okay, so I don't know if that helps. So if we look at it that way, we're going to be still in the hole. So that's kind of how I look at it. So I'm negative. I've lent out $9. Now I'm going to lend out another $4. Now I'm going to be even more in the hole, negative 13. Okay. So you just have to practice with those. There's many examples in the textbook. I really didn't assign a lot of homework just related directly to these problems. So if you feel that you need more help, I would recommend just doing the practice problems in the textbook, remembering that all of the odd numbered problems, the answers are in the back of the textbook. So if you feel like you need some help with that, I'm sure Khan Academy has some videos on it also, but hopefully that's kind of all coming back to you from previous schooling. All right. Now, when we look at multiplication of integers, this is starting on page 207. Basically, there's rules to follow where if you have two positives factors, your answer is going to be positive. If you have two negative factors, again, the two negatives is going to equal positive. Okay, and then if you have a negative factor and a positive factor, the negative always overrules, basically. So examples are, you have 6 times 4, which are both positive. You have 24 as your answer. Then you have the negative times the negative. Again, you're going to equal positive, that double negative kind of rule. And then you have the negative multiplied by a positive, and your negative always overrules. Just also, I want to mention making sure that you start getting used to seeing multiplication written like this. So you may see 8 with a dot, and then a 3, okay? Or you may see 8 with parentheses, 3, okay? Those all mean multiplication, okay? Reason being is that as we get into algebra, a lot of times x is a variable. So x, not to get it confused with it being a multiplication symbol, that it's actually a variable. And a lot of times they'll be kind of written, not always, I'm trying to see here in your textbook, usually it's italicized, okay? So if it's a variable, it's generally italicized, okay? And that variable is representing the unknown part of your equation, usually something you're trying to solve for. Okay, so division of integers kind of has the same rule, okay? So if you're having a negative divided by a positive, your answer is going to be negative. And you can always double check by, doing the reverse. So if I were to take negative 6 times 4, well, I know I have the one negative, so my answer is going to be negative, okay? So negative 6 times 4 equals negative 24, okay? Here again, you have 2 negatives, but your answer is going to be positive. So that's that double negative rule with the positive. But again, if I take 6 multiplied by negative 4, I'm going to get negative 24. And then obviously, if you're working with just positives, you're going to have a positive answer. Okay. Okie dokie. Just making sure I'm not forgetting anything. That's why I'm pausing here. All right, now moving on to exponential notation. This starts on page 209 in your textbook. So when we're looking at, for example, 3 to the 4th power, okay, this is useful for writing a product of many factors, okay? So how many times are we going to multiply out the number 3, okay? So so just make sure, this is the biggest mistake people make, is that they look at this 3 to the 4th power and they just go, oh, that's 3 times 4, and so it's 12. No, it's 3 times 3 times 3 times 3, okay, which is 81. Big difference. Okay, so just a little definition here of terms. So again, 3 to the 4th power. 3 is considered your base, and 4 is your exponent. Okay, so the exponent tells us how many times the base is used as a factor. More time, well, maybe not right now, but well, I think I do towards the end here. All right, so when we're looking at a square root of a number, so again, something times something equals the value, or so you have to have the two factors basically equaling the product. So, I'm not sure how you would like to look at it. I mean, we can kind of play around, and so if we have like 2, for example, would be this, the square root of 4 would be 2, because 2 times 2 is 4, okay? And this is 9, so I'm just going in order of numbers, 2, 3, 4. So if I take 4 times 4, that's 16, okay? Obviously, this is going to be 5. So whatever times itself, basically, it equals the number inside the square root sign. Ooh, that's a mouthful. All right, there's just probably a couple problems on that. That probably should really be review. All right, PEMDA. This is the one that kind of trips people up. Okay, order of operations. So try to remember this little mnemonic, or whatever they call it, mnemonic thing, where you PEMDA, P for parentheses and fractions, E meaning exponents and roots. This is the order that you're going to solve your problems. Multiplication, division are sort of kind of together, and then addition, subtraction. Okay, and then you always then work from left to right. So for the example of solving the problem that's given here, the first thing that should jump out to you is that you have parentheses. So you need to solve that 12 minus 8 first. Okay, So I'm just going to write a 4 up there. Okay. Then you work from left to right. Okay. You're going to do the multiplication first. Okay. So now this is basically has changed this problem to 4 times 4 plus 3. Don't do the addition first. Do the multiplication first. M comes before the A. Okay, so you're going to do 4 times 4 first, which is going to give you your 16. Then you still have to add your 3, giving you a number of 19. Okay, I do believe, yes, I do. You do have your homework assignment is page 211 on the bottom there, and you'll have lots of practice to do that. All right, now just some terminology again with algebraic expressions. A variable then is the letter or a symbol that represents basically the unknown, okay, what you're trying to solve for. And it's often represented in a number, I'm sorry, I want to say number, but I don't want to say number. A letter, alphabet, a letter of the alphabet, usually italicized, okay? And then the coefficient is the number that's placed with another quantity basically in front of that variable. So it's basically how you would treat that variable. So the coefficient then of -8 in front of the y basically means you're taking -8 times whatever the y is. So it's kind of like multiplying it, okay? So always if a variable is by itself, so any of these letters here, the s, x, or y, it's understood that the coefficient is always 1. Okay, so it's just by itself. So an s by itself really is like 1s. Okay, or xy is 1xy if they're by each other. Okay, if they're next to each other. Because you could have x plus 8y, okay, and that would be different. This coefficient is 1, this one is 8. All right. Okay, some other terminology too, and this will help with story problems or word problems where you have to understand what is it really asking, okay, and this can be kind of tricky there. I know there's a test question that always trips people up, and it's like, I think it's the quotient, or I can't remember exactly, but I'll point it out when we get closer to it. But just kind of realizing what these words are meaning, what they're asking you to do, okay, in the word problem. So obviously is, as, equals, equals to is hopefully equal to your equal sign. Add, sum, plus, total, more than, increase by means you're going to add. Subtract, your minus sign. Subtract, difference, minus, remainder, less than, decreased by, all means that you're going to be subtracting. X is basically saying, you know, if it's set up that way, mainly it's saying, it's the flip-flop, it's the word, and it's going to tell you what the operation should be. So if it's using multiply, obviously you're multiplying. Product, times, of, okay? And then divide, you may see being represented by quotient, split, per. Okay, so just read through those word problems really carefully. And I'll probably spend more time on that on the next. You have a little bit in your homework this time. We will be spending more time on that on the next PowerPoint. All right, a couple more slides left here. I sure hope this works. Let's see what happens when I have to convert it and upload it, and all that good stuff. All right, so word problems. Again, this is what we were kind of talking about. Reading these very carefully, paying attention to the details. Okay, so if it's saying 5 more than x, okay, that's pretty straightforward. So that's x plus 5, okay? 5 is more than x. okay, then it could look more like 5 is greater than x. 9 is less than some number, then your x is going to be minus 9. Okay, so again, they're kind of tricky. I've got another example here coming up. 4 times the sum of 3 numbers. So first of all, you have to, the sum of 3 numbers is going to be in parentheses. Okay, and then 4 times is going to be on the outside of that parentheses. So here's your 3 numbers that you've add, and then 4 times the sum of those 3 numbers. So just read through the problems really carefully. All right, so here's kind of, and then of course, as we are trying to solve problems here, we are trying to get the variable by itself. So isolate the variable, okay? So this should be kind of review if you've had hopefully algebra in the past or even pre-algebra. You want to get the x on the one side of the equation. So that's basically remembering that you have to do the same thing to each side of the problem to do this, okay? Addition being the inverse of subtraction and vice versa. Multiplication, the inverse of division and vice versa. So for our example here, we have 5 plus y equals 7, okay? So we need to get the y by itself. So how do we do that? Well, we have to subtract the 5, right? Get rid of that 5. So in order to do that, on this side of the equation, we have to minus 5, okay? So that gets rid of it. But then we have to do the same thing to the other side. So here's where we do the minus 5 on that side. So now we have y equals 2. Okay, so look at the problem here in the box. We have 3 times x equals 17. We need to get rid of that 3. Okay, so that's a multiplication. So we're going to have to divide this side by 3. That'll get rid of the 3. But we have to do the same thing over here. Sorry. We have to do the same thing over here. Okay, so x equals then 17 over 3. And if we were to work that out, let's say we want to work that out just for, you know what, and giggles. When I get in the classroom, I'll feel a little more comfortable. Okay, so this is 15. I know that 3 goes into 17 5 times. Okay, so that's 2. And I have a decimal here now. Okay, I can't get 3 into 2, so I have to add a 0. So what's that, 6? Oops, darn it. 6 would be 18. And a 2 again. So this looks like it's going to repeat. So it looks like to me it'd be like 5.67 if I were to really work it out. I'm just going to look on my calculator for fun here. This is really, I think, close to our last problem. So 17 divided by 3, yes, it's 5.666666. So yes, 5.67. All right, as you can tell. Okay, so here was the blank slide that I apologize, I should have had that in a little bit earlier, to talk again about scientific notation. Okay, so here's another example. If I have this number, I have 9.647 times 10 to the 7th, and I want to write that number out in standard form. Okay. So does that mean I have 7 zeros? Here's my decimal. No, we don't have 7 zeros, but we have 7 place values. Okay, so this should equal then 9. Now here's 3 of my place values of my 7. Okay, 1, 2, 3. 1, 2, 3. 4, 5, 6, 7. So here should be my number. 96,470,000. Okay. All right. What about, I'm going to flip-flop now, and I'm going to, let's do a different color. I'm going to look at this one, 53,010,000. And I want to write this one out in scientific notation. So my first number, these are zeros, my first number is 5.3, okay, 5.3. And I'm going to go ahead and carry that out to where I don't have any more zeros. I'm going to say 5.301. Okay, I'm trying to make a dot there. It's not allowing me. All right, so, but how many place values am I to the right of my decimal? Right here is my decimal. Times 10 to the 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. Okay. All right. I'm going to do one more here. We'll do this one in green. Okay, so standard form, my number is 0.0. I'm just going to put a little X there so you know that's where my decimal is. 0.052, okay? Or what is this? 52 thousandths. THS, okay? Now this doesn't show up the best. 52 thousandths, okay? So because 52 thousandths is telling me then, again, that my decimal initially is to the left of my 52, okay? So I'm going to put my first number is going to look like 5.2, okay? I wonder if I should change that color. I'll change it to purple. 5.2 times 10, and how many place values am I from here? 1, 2 times 10 to the -2, okay, because I had to move my place value was originally, it was a negative because, well, the TH tells me that was on my other side of the, that was less than 1, basically. So less than 1 in standard form. So 52 thousandths is telling me that right there it's going to be negative, that my decimal is going to be to the left when I write it out in standard form, like this. Here's my standard form, this being my word. And so then, because I had to move my decimal then, well, I had to move it to the right to do it here, but because my number is less than 1, my exponent's going to be negative. But again, watch your Khan Academy. That should definitely help you. Okay.